We
Okay,
have, we
we
have
have a winner here.
perfect.
All right, we got there. All right.
Very good, Shailesh, Printed Energy, joining us out of California. Um, with that, Shailesh, the stage
Sure.
is yours.
Thanks, Chris. Yeah. So as all of you, all of the folks know that one does not need to be an economist or a scientist or an engineer to understand the growing need for electric energy generation and storage. Like increasingly, our daily routines involves making sure we have everything plugged in: devices, IoTs, vehicles, even aircrafts, everything we're plugged in. So if you think about the global market, if you if you trust the economics, they're expected to grow from 100 billion to a 400 billion US dollars over the next 7 years. Given that, printed energy is poised to be a very critical player in that market and providing a promising future. So today's focus is on material technology, specifically for flexible thin batteries. Even though the technology has been around for more than 10 years, as you can see in this table, the commercialization has just started. And this gives us a very exciting opportunity and a roadmap for the industry. As the saying goes, the journey of 1,000 miles begins with a single step. And after many years of hard work and science, the commercialization of low power batteries is continuing to develop solutions and over time develop into high power uh, applications. So there are multiple technologies that exist today, specifically for printed batteries. Some are environmentally safe, while others have negative impact on the environment, which a lot of us know, and material shortages. There are also challenges with high volume manufacturing for some of the materials, such as solid state. Today's discussion will focus on zinc manganese oxide batteries, its advantages, state of development, and applications. So, why zinc manganese? They promise a safe and reliable energy source. They are widely available and will be more of general availability as the primary batteries for small scale consumer electronics because of the low cost and high energy density. Because of the abundance of the material, there has been acceleration in research to make this chemistry rechargeable by materials engineering, additives, and experimenting with various electrolytes. Thus, important contributions have shown these type of batteries has all the prerequisites of the post-lithium solution for large scale. And these are environmental friendly. That is one of the biggest importance of these type of batteries. So what are some of the challenges in development of zinc manganese batteries, right? Zinc oxidation is one of the biggest challenge because they rely on ambient condition. Exposure to environmental factors such as water, oxygen, and acidic or alkaline electrolyte will block required reactions because this is all based on chemistry. It's chemistry. Batteries in general are based on chemistry reactions between materials. And because of these reactions and exposure to these other external factors decreases the capacity. And in certain cases, the hydrogen evolution, where the evolution can damage and destroy packaging and the batteries will stop functioning because of the reaction that happens. And for specifically for rechargeable, when the zinc reverses to the original state, it can form crystals. And once crystals are formed, it creates shorts in the batteries. So these are some of the key challenges that the scientists and new organizations and companies are working to see what can be done to help resolve these challenges. Next, we'll jump into manufacturing processes and advantages. So for zinc manganese type of batteries, because of the manufacturing used for these type of batteries, it provides flexibility to design batteries around the design of electronics. So as they say, any shape, anywhere. So again, as you can see, a kangaroo shaped battery. So basically, you could take electronics, understand what requirements are for the